Hey y'all. This week I chose to read 2 chapters from the second section of my textbook. This section is a focus on learning, and the authors explain that everything's a focus on learning, but the research is more structured on how students learn here, and that's kind of the focus. So I chose chapter 9, which is the first chapter in that section, because the study was looking at 5th graders and how they can count cubes in 3D arrays and then use that to come up with their own formula for volume. So I chose that one because my daughter's in 5th grade and she's actually studying volume right now. So I thought this would be kind of neat, and I ended up saying, you know what, I think I can use this in my college readiness math. We have a unit to review geometry, volume of solids, and things like that, and I thought I might use something similar. So the study was on, like I said, a group of 5th grade students, and a teacher used this really neat activity where they look at a pattern picture, kind of like a 2-dimensional picture that's laid out, and then they look at a box picture, so a 3-dimensional picture. And the students were supposed to look at those 2 pictures and then determine how many unit cubes could fit in the boxes. Then they actually constructed the boxes and tested it. So that was really neat. And what the researchers found was that having the students first predict, so they had to predict it first, come up with a way. Then they would check it, and then they would talk about why their predictions were wrong, and come up with a way to predict without actually creating the box every time. And having them predict and then check it was essential. Also, having them work and talk about it in collaborative groups was also essential to the learning goal here. And really and truly effective communication was the key factor in determining the group success. So if you had students that weren't communicating appropriately, they tended to be less successful, which most teachers would say, yeah, absolutely. So the key thing was that students need to have opportunities to be like scientists. Even in a math classroom, they need to have the opportunities to make some mistakes and struggle to help them make sense of ideas. And also that the teachers have to know what struggles students need to encounter to build these ideas. So as a teacher, our job isn't just to let them sit around and struggle, but to carefully construct tasks that allow a productive struggle. So I thought that was really cool. I'm definitely going to be using that task. And the next chapter, I'll find that one for this week. The next chapter that I looked at was chapter 13, and it was an exploration of language proficiency and algebra learning. And I chose this one because I have, in the last 15 years, have taught mostly algebra, algebra 1 and algebra 2. And I've always felt like if students they don't understand the structure in sentences, I see that disconnect. So this was really interesting to me. I was actually really excited to read it. So it focused, I like the beginning of it. It said, we normally, when we focus on linguistic studies, we focus on subgroups, non-English speakers, and they're learning English. But this study, they wanted to look deeper into their what they called metalinguistic awareness. And so that refers to like their linguistic ability that allows a language user to reflect and analyze the written word. And so I like this example they use in the text. It said an example is a child noticing that school rhymes with pool and rule, but then they wonder, why is school not spelt like rule? So not just hearing those words, but analyzing the structure. And I thought, yes, you know, that's kind of what algebra is about. So the study found, they actually had some initial difficulties in the study. They made their English test a little too easy. So everybody did well in English, and then, you know, they had some that didn't do so great in algebra and some that did. So they said, all right, we need to make this English test a little more robust. And so they added things like metaphors and some other things. And what they found is that, in fact, there were correlations between language and algebra scores, and that were positive. So, you know, as one increased, the other also increased. So there were some really cool conclusions from this data, like, should we make sure that students have developed this linguistic awareness or this meta-linguistic awareness before we introduce algebra? And should we make sure they've mastered that before we move into algebra? And then a lot of times people would say, oh, you know, well, ELA and math are so different. If you're not real good in ELA, you know, you can still, you know, do great in math. But as we get into really analyzing algebraic structure of expressions, it might not be the case. We might truly need that ability to structurally analyze words, sentences, and algebraic expressions. And that's all for this week.